Welcome to section 21.4. This is the 212th session of the CISSP exam prep series. In this session, we'll focus on injection, one of the most common ways attackers break into applications. We'll answer several questions. What is an injection attack at its core? How does SQL injection work? What happens when the attacker cannot see the results? What is code injection more broadly? And how does command injection reach the operating system itself? Why does this matter beyond the exam? Because injection flaws sit near the top of every serious list of web risks. Picture yourself reviewing a customer portal for a healthcare provider. A single search box that trusts user input can expose every patient record behind it. When you understand exactly how these attacks are shaped, you can spot the vulnerable code and demand the right protections before the portal ever goes live. What is an injection attack at its core? At heart, it is tricking an application into treating your input as instructions instead of data. The attacker supplies specially crafted input, and the application either executes it or passes it to a back-end system that does. We usually name the attack after whatever it targets or the payload it delivers. So you will hear of SQL injection, command injection, and many others. The common thread never changes: untrusted input crossing the line into code. Think of slipping a forged order into a stack of paperwork and watching the clerk carry it out without question. How does SQL injection work? Many applications take your input and stitch it directly into a database query. Normally you search for a product and the app builds a tidy query to fetch matching items. But if the app blindly glues your text into that query, you can add your own database commands to it. A crafted entry can close off the intended query and append a second one, say, to dump customer names and card numbers. Because commands can be chained, the same trick can also modify records, drop entire tables, or wreck availability. This is why input must never be trusted as part of a query. Picture handing a librarian a request slip that secretly also says, "And bring me everyone else's private files too." What happens when the attacker cannot see the results? Many vulnerable apps never show the query output, but that does not make them safe. Attackers turn to blind SQL injection, and the first flavor is content-based. Here, the attacker injects a condition that is always true, then one that is always false, and simply watches how the page changes. A true condition returns the normal record, a false one returns nothing, and that difference alone confirms the flaw is real. It is slow and indirect, but it works. Imagine probing a locked room by asking yes or no questions and reading the guard's reactions. Is there a way to attack when even the page looks identical? Yes, through timing-based blind injection. When the content never changes enough to read, the attacker uses the clock instead. They inject a command that tells the database to pause for a set number of seconds before responding. If the page comes back instantly, the app is probably safe, but a deliberate delay reveals the vulnerability. Cleverer still, an attacker can extract secrets one character at a time by asking, "Does this letter match?" And if so, wait. Tools automate this until an entire password falls out. Think of knocking on a wall and timing the echo to map what is hidden behind it. What is code injection more broadly? SQL injection is just one member of a larger family called code injection, where attacker-written code slips into the developer's legitimate code. Any place that folds user input into executable instructions is a candidate. The same idea targets a directory service in an LDAP injection, an XML backend in an XML injection, or even tries to load a malicious dynamically linked library. A modern twist involves large language models, where a downstream system blindly trusts the model's output and passes it along unchecked. If an attacker poisons the prompt, the model can return a hostile payload that the next component dutifully runs. The lesson is universal: validate and escape input, and never blindly trust generated output either. How does command injection reach the operating system itself? This is an especially dangerous cousin, because the target is the server's own command line. Some applications reach back to the operating system to run a command, perhaps creating a folder for a new user. If the app drops your raw input straight into that command, you can smuggle in a second command of your own. On many systems, a simple separator character tells the shell, "And now run this too." An attacker can turn an innocent folder creation feature into an instruction that deletes entire directories. Picture a vending machine that takes your button press, then also executes whatever you scrawled on the coin slot. The defense, as always, is rigorous input validation before anything touches the shell. So let's bring it together. Injection means tricking an app into running your input as instructions. SQL injection folds hostile commands into database queries, exposing or destroying data. When results are invisible, blind attacks read the page's content or its response timing instead. Code injection generalizes the idea across directory services, XML, libraries, and even AI output. And command injection reaches all the way to the operating system shell. Every one of these bows to the same discipline: validate and escape untrusted input. Always. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.